right, so this is Leetcode 206, reverse a linked list. So you can see we've got a list of nodes right here, and the goal is to update their pointers so that they reverse. Pretty simple to conceptually understand, a little confusing maybe to visualize. So the first thing we should do is let's just console.log this head variable they give us just to see what we're working with. So when I console.log this, you can see they give us an array, but it's actually nodes that are linked together, and they are linked together with this syntax. They have a next, which points to the other node. So if I was at node 1, it would point to node 2, and node 2's next would point to 3, and so on. And then they also have the value. So, the value of node 1 would be 1. So with that in mind, we need a way to, let's just traverse the list first. So I'm going to say while head equals head.next. And before I do head.next, I'm going to console.log head.val. So what I'm saying here is while the head node is valid and not null, it's a truthy value, so it actually exists. Then I want to log its value, and then I'm going to make it equal to the next node that it points to. So this way we can kind of daisy chain and move down the line and print out every individual node. So let's run this. You can see we're printing out every individual node's value. So that looks good. So we need to reverse their pointers so they don't point to this way, but they start to point the opposite way. So 1 would need to point over here, 2 would need to point to 1, 3 would need to point to 2, 4 would need to point to 3, and so on. So the first thing we need to do is make a previous variable, and we're going to set that to null, because when we start at 1, there is no previous node to 1. It's just node is the head. Okay? And I'm actually going to delete this code inside here. We can leave the while head because that's going to help us traverse the list. Now, the thing that kind of trips people up on this is we need to store the value of heads next, which in this case would be 2. We're doing this because we're going to change it, but we need to remember that old value. So let's make a variable called next, and it's just going to be head.next. Okay? So we've got this logic in place. Now we actually need, as we mentioned before, to change the pointer on 1 so its next value does not point to 2, but it points to the previous node. So I'm going to say head.next equals prev, just like that. So now 1's next pointer is pointing to a prev value which is initially set to null. Now we need to update null, not for this iteration, or sorry, we need to update prev, but not for this iteration. We need to update it for the following iteration. So I'm going to say prev is equal to head. So that is going to have prev be fired up and ready to go in the following iteration. So obviously we're setting next to prev, and prev right now is null, but then we're coming down here and saying prev is head, so now prev is going to be 1. Right? It's going to be that 1, but it was head.next was initially set to null. Okay, so you're still following with me, I hope. Now we need to update the value of head.next, right? Or sorry, we need to update the value of head to the next value. So I'm going to say head, and then that value of next we stored here, I'm going to say that. So basically, I'm now having the head point to the next value which we stored here. So using this logic with these two lines of code, you're able to progress the list. Meanwhile, this code right here is actually having the nodes point backwards. So we're able to still progress the list while changing their pointers. So now, if we console.log prev, it should return it backwards. And that is what we've got here. So let's return prev. And that looks pretty good. Submit it. Cool. So if this doesn't make sense right away, it is kind of a conceptually challenging problem to wrap your head around. And hopefully my explanation helped a little bit, but it is one of those where you kind of got to like get out the whiteboard and see what's happening. But the thing that I would say is that next, like storing the head.next pointer in a variable is basically what you need to do just to get the list to progress, right? Because you're going to change the actual next pointer to the previous value, and then you're going to update the prev for the following iteration. So these are actually changing the pointers, where this code right here is just used to progress through the list, but these are actually like updating the pointers. All right, well, that is Reverse Link 206. I hope you guys enjoyed the video. Thank you for watching.